Hello, welcome back. In the previous lecture, we explored the SVC assembly instruction. As now, using SVC assembly instruction, system call in Linux can be invoked. Now, we will practice debugging about how the SVC assembly instruction works. So, program you are looking at is the TRACE32 and debugging program. This window indicates the general purpose registers along with the exception level. Then here is the instruction window that shows you the address along with assembly instruction. Now let's focus on this icon. This icon indicates that the current exception level is exception level 0. So now we are about to run the SVC assembly instruction where the current exception level is exception level 0. As you know, the before SVC assembly instruction, so we can notice that the system call numbers can be written to X8 register. So because SVC instruction is used to invoke the system call in Linux operating system. So now, let's run this assembly instruction first. I will click this icon. Please look at this. X8 register is updated to this value. So X8 register now contains the system call number. At this point, we are about to run SVC assembly instruction. As you know, when we run SVC assembly instruction, Arm core will perform the two things at the same time. First thing does is to switch the exception level from exception level 0 to exception level 1. At the same time, the parent counter is branched to exception vector address. The way to calculate exception vector address can be seen here. That is, offset the direct 400 should be added to the value of the V-bar ER1 system register. Please note that this system register holds the exception vector base address. This is a way to calculate exception vector address. Now, let's execute SVC assembly instruction. So, by running this assembly instruction, you are going to see that the exception level will be switched. Now, here we go. 1, 2, 3. Please look at this. Now, the current exception level is exception level 1, not the exception level 0. And another thing we can see is that the parent counter is branched to another address. Now, the parent counter holds this address. Please look at this. The value of the parent counter, this value is corresponding to the gray bar in the instruction window. This address is identical to the value in the parent counter. So the reason is the V-bar, the ER1 registers hold the exception vector address that is about the address. So for better understanding, let's take a look at the value of the V-bar ER1 register. For this, I will navigate the menu from CPU. Please look at this. Then peripheral, then let me choose this icon. System, control and configuration. So let me take a look at the value of V-bar ER1 register. Please take a look at this. The value of V-bar ER1 register. So V-bar ER1 register means vector base address register. So let me copy value of V-bar ER1 register. So here is the value of V-bar ER1 register. Then this is offset for the synchronous exception in this case. So by adding this offset value, so we can calculate exception vector address, that is this address. So this address is identical to this address in the parent counter. Please look at this. Here, this is our instruction panel. So this the parent counter is indicating that this the gray bar. So now at this point, if you run this assembly instruction at exception some vector, the address, then you're going to see the several assembly instruction can be seen. Those kind of assembly instruction is called the exception handler. So if I click, so this one, and then the parent counters move to another label that is called ER1 sync the label. So main responsibility of this label is to store the general pop-up register at the moment of exception into stack area. Then this label will perform another important operation later. We will read the value of the XA register to check the value of the system call number. Later, the corresponding system call handler will be a call. Now, let me use r.undo command. Please look at this, r.undo command to revert the last executed command. So this command is supported in TRACE32. So let me click again. Please look at this. I will keep on using this command. And this command that will revert last executed assembly instruction, as you can see. Please look at this. Okay. Now we reach it, the SVC assembly instruction. Now at this point, what you can see is this r.undo command also restore the previous state. That means, as you can see, the current, the exception level is exception level 0. Now let's resume the debugging practice again by running SVC assembly instruction. So please pay attention to value of this icon because we will be changing it as ER1H. This means that the exception level is exception level 1. And then the parent counter will be switched based on the value of the V bar ER1 register. Now, so let's continue. Here we go. Now what you can see is the current exception level is switched as exception level 1. Then the parent counter is branched onto the exception vector address.